All right, so where we left off yesterday was here with the taiga, or the boreal forest. Grayson, can I have you just turn off that front light switch for me, please? Thank you. All right, now the taiga, or the boreal forest, like we said, it's, we can see it from here. It's the stuff that grows up the side of mountains in the Kananaskis and Banff and Jasper. Okay, it's also the biome that is present throughout all essentially of the northern parts of the prairie provinces. Okay, it's, I mean, if you've everyone gets this idea that Saskatchewan's, boring and flat, and a lot of it is. Okay, when you're in southern Saskatchewan, you can see from one side of the province to the other. Okay, or you can watch your dog run away for a week. Insert whatever flat Saskatchewan joke you want here. Okay, but the northern part of Saskatchewan is very much like the northern part of Alberta. It's boreal forest, it's lakes and rivers and stuff like that. Okay, and again, very rich in resources, very rich in lumber resources, obviously. Okay, but also oil and gas and things like that. All right, the big thing about this is it's a dry forest. It's not like a deciduous forest that gets even rainfall all year long. Okay, the boreal forest is actually quite dry. Pine and spruce are very drought tolerant trees. Okay, and they have to be because the majority of the year the ground that they grow in is frozen, and you can't extract water when it is in ice, or when it's frozen as ice. All right, so it's a very dry biome, and when snow begins to melt, it tends to run across and not seep in. Okay, it's a weed eater, guys. That's all. Okay, give you an idea, climatogram for this. Okay, obviously there's very distinct difference between winter and summer in the boreal forest. Okay, we're talking in the winter time minus 45 to minus 50, in the summertime plus 25 to plus 30. That's a huge temperature variance. There's only certain types of plants that can tolerate a temperature variance like that. Okay, and the majority of them are boreal forest types of trees and undergrowth. You can see here again, looking at the rainfall on the climatogram. Okay, the rainfall is relatively even. It does tend to peak a bit in August and September, right? But it's much, much lower, right, than it is in the deciduous forest, even on the prairie. Okay, the wettest month here is 50 millimeters of rain. About that much, 5 centimeters. That's the wettest month. So it is a very dry biome. Because it's very dry, forest fires are a big problem. Right. Well, they're not so much a big problem as they happen often. Okay, forest fires are actually an important part of the boreal forest in that it helps to cycle the nutrients and actually keep things healthy. What you don't want is a really old growth forest that gets, sick easily and is susceptible to insects and blights and other kinds of things. And this is what happened in Kananaskis and in Banff a few years back when they had the pine beetle infestation. All right. In Kananaskis, Banff, and Jasper, the national parks and provincial park system had been forcefully preventing forest fires for 100 years. What that produces is large tracts of forest that are old and sick, that should have burned years ago, but were not allowed to. And then what you end up getting is a whole bunch of fuel sitting around that's just waiting for a spark. All right. Now, the other problem that you have is trees that are old can't defend themselves against insects and blight, and so you get pine beetle infestation. And once the pine beetle gets going, it can even go after healthy trees, and that's what ended up happening. And what they had to do was actually have controlled burns and burn big sections of forest that should have been allowed to burn 50 years before. Okay, so it's important that fires come in because they cycle the nutrients through. They help to open up new seeds. Like most of the trees in the boreal forest, their pine cones are fire activated. All right, so they're sealed up with a resin, and then when they're burned, the resin melts and the heat expands the pine cone and the seeds pop out. So the seeds don't actually get onto the ground until the plants that produce them are dead and are no longer competition for their little saplings. Okay, so it's actually really smart to do that because you time your growth when there aren't other organisms to compete with you, but they're still standing and providing a little bit of shade for when you're itty bitty. All right, everyone kind of follow me there? All right, so that's kind of how a forest recovers after a fire. Okay, obviously winter is a big problem, can persist for up to 3/4 of the year, okay, 4 months of summer at the most, okay, things like that. So runoff is very important, okay, since approximately half of the annual precipitation is released in 1.5 to 2 weeks, okay, that's the heavy melt in the spring when all the snow just melts away and runs off, okay. You got lots of steep hillsides and things like that, so it's difficult to absorb all of that moisture. Everyone with me there? All right. Vegetation, we said before, Canadian forests are very different from tropical forests. The diversity is much different. We said in a tropical forest, there could be up to 50 different kinds or 100 different kinds of trees in a 100 by 100 meter area. All right. In a Canadian forest, there might be 4 or 5 different kinds of trees in that same area. Right? It's just not that diverse. It all looks the same. When you're standing on top of a mountain and you look down at the forest, every tree looks the same. Okay? Because most of them are the same species or at least very closely related. Right? And you can see in this picture, pretty much everything in there is either a black spruce or a Douglas fir. Okay, there's the occasional lodgepole pine in there as well, okay, but it's just not very diverse at all. And obviously, you got a few undergrowth species like fireweed, some grasses, maybe a few ferns here or there. Okay, but again, not a lot of diversity. Okay, soils in the taiga tend to be very poorly developed because they're frozen so much. So there isn't a lot of activity there to build up organic material. The other problem is that most of the plants that grow in that area don't drop their leaves. Okay, they're evergreen. They drop needles once in a while, but those needles make the soil very acidic, and that prevents other things from growing. If you've ever noticed in front of someone's house who has a big spruce tree or big pine tree in their front yard, nothing grows underneath that tree. Right? That's because the needles produce an acid that actually prevents things from growing around the tree, so nothing can compete with it for water and nutrients in that soil. It's a survival strategy that they have. Okay. All right, animals. Animals in the taiga have to adapt to long winters. There's 2 ways to do that. You can either migrate and get away, or you can stay. And if you stay, you might want to hibernate, okay, during that time. If you don't, you're active and you have to be well insulated. All right, so obviously the ones that migrate we're not as concerned with. They're only there in the summertime and then they're gone for the winter. Okay, the ones that stay for the winter, like the ground squirrel, will go into not so much a true hibernation as they'll go dormant. Right? And what they do is curl up into a little ball and they drop their body temperature, they lower their heart rate, and they hardly breathe at all. Okay? We're talking a little squirrel like that, their heart might beat 5 to 10 times a minute. They might respire once or twice a minute. If you were to pick them up, you would think they were dead because they would be a stiff, cold little ball. All right? Occasionally throughout the winter they'll wake up, okay, and when they do, they spend about a half an hour to an hour shivering in order to get their body temperature back up to some reasonable number, and then they'll feed on some of the seeds that they've stored through the summer, and then they'll go back into their dormant condition. Okay, everybody follow me there? That's the squirrel. Squirrel curled up in a ball. Okay, see, here's his eyes, and there's his little ears. That's his tail. Greenish brown, yeah. Ground, like a Richardson's ground squirrel, right? Yeah. Right. And then what's this thing? That's a wolverine, yeah. Okay. And there's a reason the X-Men character is named after these things, because they are vicious. Imagine the temperament and aggressiveness of a grizzly bear packed into an animal about the size of a German shepherd. Okay. You do not want to mess with one of these things. They will rip you to shreds and chew on your bones. Okay? They are very, very protective of their territory and very, very aggressive. All right. That said, they're also highly endangered because they have valuable fur, and a lot of people will trap them and sell the fur. Okay? In terms of other sort of winter adaptations, many animals use the snow to protect them. Okay, and we talked about this the other day, how snow is full of air pockets and it can provide insulation. Okay, if you've ever built a quinzhee, okay, a quinzhee can get very warm. It's just an emergency snow shelter. All you do is pile snow into a big pile and then you hollow it out and crawl inside. Okay, and you can get the temperature above 0 inside of there. All right, everyone with me on that? Okay? You can actually get the temperature above 0 inside of a quinsy. It actually starts to, you get little drips falling on you until it forms a crust kind of around you. Right? Has anyone ever built one of those before? Okay. When I taught in Lloydminster, we would build one every winter as part of the snow ecology unit that we used to do. Okay, and you wouldn't believe how fast people can make a pile of snow and hollow it out when it's minus 40 outside. Okay, but they would get it dug out, they would get inside and just put a garbage bag over the opening, and within a matter of about 10 minutes, it would be plus 10 inside. All right, simply because you got 4 people in there whose body heat is coming off of them and reflecting off of the snow. Okay, the snow is insulating; it's not allowing it to come out. Okay, and it just comes back on them and it gets nice and warm in there. People are shedding layers like crazy when they get in there. All right, so animals will use the insulative properties of the snow to protect them through the winter. Problem is if that snow gets compacted, then all that air gets forced out. Right? And when that happens, then it's no longer insulative. Right? So snowmobile tracks and things like that are a big deal, okay, for those kinds of animals. All right. Changes in light are also an important part of the taiga, because obviously the further away from the equator you get, the greater the tilt of the Earth's effect on your daylight is. Okay, and we know that in a lot of places in the taiga, it doesn't, you only get about 4 hours of daylight. Okay, in sort of those more northerly parts because of the tilt of the Earth. That is usually what cues animals for their either migration, hibernation, and mating. Right? When the days start to get noticeably longer, okay, then oftentimes animals will time their mating so that they're having their young as the days are getting longer, because as the days are getting longer, their food sources are going to be more plentiful. Okay, and okay, they're gonna have a much better chance to survive. Migratory animals, that's cued by the shortening of the days. Okay, that's when they'll decide to leave. Okay, chemical cycling, really, really slow. All right, lots of times you go into Banff or Jasper, places like that, you see fallen trees. Those trees have been down for 10, 15, 20 years, okay, because it's cold through the winter and there's not a lot of fungus and bacterial action through the winter. Okay, there's only 2 or 3 months of the year where decomposition actively occurs, and so decomposition is very, very slow. All right. The tundra biomes. There's 2 different kinds. There's Arctic tundra, which you have when you're very far north, like let's say up in the northern Alaska and places like that. It's so cold that it's too cold for the boreal forest to grow. So you have an Arctic prairie, essentially. Okay? You can also see them in the alpine, above the tree line. Okay? So above the tree line, you're into alpine tundra. Right? And what you see there is basically just shrubby kind of bushes, maybe grasses, and kind of really hardy plants that can survive, only being able to grow for about 2 months of the year. Okay, so daylight, obviously, in the wintertime in the Arctic, above the Arctic Circle, in the winter you have 24 hours of darkness, and in the summer, okay, right about now actually, they're having 24 hours of daylight. Okay, so the sun never sets in the summertime, the sun never rises in the wintertime, okay, for about a 3-week period around the solstices. Okay, you guys know what I mean by the solstices, right? The summer solstice is coming up, longest day of the year. Okay, winter solstice, shortest day of the year. All right, mountain tundra, okay, our alpine tundra is exposed to not only thin air, but because of its high altitude, also high in ultraviolet radiation. The plants that grow there have to have thick cuticles to protect them from getting a sunburn. All right, sunburn can be a problem even for plants. All right, climatogram for the tundra. I know this makes it look really wet, okay, but when you look at the actual numbers here, we're looking at 60 millimeters of rain in the wettest month. Our last one where we looked at the taiga, the wettest month was 50. So while this looks a lot wetter because the bars are taller, it isn't. Okay, it's about the same amount of precipitation as the taiga gets. All right, but you notice here the biggest thing is the bell curve for the temperature. Here's 0 degrees Celsius right here. Right? Most of the year, it's what? Frozen. All right? We've only got really, okay, June, July, August, and maybe part of September where the temperature on average is even barely above 0. All right? The warmest month here on average is about 7 degrees Celsius. Okay, so very, very cold conditions. And obviously the coldest months, okay, we're looking at like February minus 26, okay, or colder even. Making sense there? Okay, and then vegetation, tundra means treeless, so it's above the tree line. Okay, you're going to see grasses and shrubs and lichens and mosses and things like that. Snow cover is really important. Without the snow cover, there's no insulation for those plants, and there's no protection from ice crystals as they blow across in the winds. And in the wintertime, when that happens, that kind of abrasion can be like standing in front of a sandblaster. Okay, and it just rips these plants to shreds, peels the bark off of little trees and things like that. So snow cover is absolutely crucial, which is why usually in the tundra you'll see bushes and stuff growing in patches. Okay, and those patches are usually where snow drifts and covers them up and protects them through the winter. All right, and that's all there is. Okay, I think your notes might actually have the extreme desert on them as well. Okay. But that's the last of it. No? Okay, don't worry about it. All right, now we'll look at your review sheet here. Okay, so quick unit exam review here, guys, for this unit. All right, you might want to write a few of these things down there. Okay, first topic we covered in this unit, okay, was climate. All right, and the big thing for climate is to know the difference between the components of climate, that is temperature, precipitation, light, and wind, and the factors that affect those components. Okay, those factors, okay, being latitude, altitude, okay, proximity to mountain barriers, proximity to the ocean, centers of high and low pressure, patterns of prevailing winds, all those things we talked about in that lesson, in lesson 1. All right, how are you going to be asked about that? Practical application question. I show you a map, I show you a spot on that map, and I say to you, describe what you think the climate of this area will be like, that is, precipitation, temperature, light, and wind, based on the factors you think will most affect that location. Basically, I'm asking you to do what you did in the climatograms activity. All right, here's a location, and then it'll be one you're familiar with, okay, so you won't be guessing. All right, tell me about it, okay? Tell me what factors you think affect it and how they're going to make the climate the way it is. All right, climatograms, obviously we talked about that. You're going to be given one, and you're going to be asked to interpret it and match it up with one of the biomes we just finished talking about. All right, so you're going to have to look at the temperature, look at the precipitation, tell me where you think it is, and justify your choice. All right, remember you need to justify your choice. On a 5-mark question that says, here's a biome, place it with a, or sorry, here's a climatogram, place it with a biome, just writing tropical rainforest will get you 1 mark. Okay, make sure you tell me why you think it's going to belong with the tropical rainforest. So it's going to be combining biomes with interpretation of climatograms. Okay, energy transfers on Earth. Okay, we need to know about the atmosphere, the lithosphere, and the hydrosphere, okay, because those are the parts of the Earth that encounter the solar radiation and are responsible for distributing it. Okay, we have to remember that the atmosphere is the most important of those 3 because it's the most fluid of the 3, and convection can occur in there. Convection is also known as wind when it happens in the atmosphere. Okay, wind can move air masses that may contain a lot of moisture, i.e. latent heat, okay, from one place to another. You got the jet streams in there, okay, all of that kind of stuff. Okay, remember that the lithosphere, the amount of radiation that it absorbs is based on this, okay, on albedo. Remember the darker colors, okay, have a lower albedo than lighter colors, okay, so the more reflective something is, the higher its albedo is. All right, and then for the hydrosphere, obviously convection is a big deal there. Ocean currents, things like that, okay, are important for transferring energy. All right, this is also, okay, going to go in with possibly design a structure that could keep something hot, or design a structure that could keep something cold, and in which case you're going to have to tell me how you think you can stop convection, conduction, and radiation from occurring, or how you can harness them and make them transfer energy to it, depending on the situation. Okay, remember also 3 things can happen to energy when it encounters any place on Earth. It is either going to be absorbed. If it is, there's an increase in energy and thus temperature. It can be reflected, very small or no change in energy and temperature. Okay, and it could be converted by photosynthesis, okay, changed sunlight into food energy. All right, those are the three things that can happen. I guarantee you'll be asked about that. True. I will in a minute. Okay. Okay, you also had that lesson 4 on global wind patterns. Okay, so we need to know about what, particular winds, the trade winds, the jet stream, the Coriolis effect, and how it's the spinning of the Earth combined with convection that causes winds to get deflected, okay, in one direction or the other. So make sure you go over that stuff. Okay, that was one of the ones you watched when I was not here. All right, if you have no idea what I'm talking about right now, you'd better watch it again. Okay, in fact, guys, honestly, over the weekend, there weren't that many lessons for you to watch. You might want to watch lesson 1 again for sure, lesson 2 again, and lesson 4 again. Okay, those are big ones. Sorry, lesson 3 again, not lesson 2. Lesson 2 is the climatograms. Lesson 3 was the energy budgets one. Okay, so lesson 1 on climate, lesson 3 on the energy budgets, okay, and lesson 4 on global wind patterns, right? There's lots of stuff on those. You need to make sure you know them. All right, so again, with the winds, Jetstream. Jetstream was that high-speed, high-altitude wind that helps to transfer energy from different latitudes, as well as latent heat from different latitudes, and that can cause changes, rapid changes in weather. Okay, talked about heat capacity. Probably going to have some problem solving to do with that. Got to be able to use E equals mc delta T. And latent heat. You're going to get an energy curve or a heating curve of water problem. Okay, remember that looks like this. Okay, and you're going to have to identify your starting and ending points. Use E equals mc delta T, E equals mlf, or E equals mlv. Okay, in order to solve how much energy is being used to heat either ice or water to another temperature. Okay, so yeah, something like this. Okay, make sure you remember that shape. I will not give you the heating curve of water. I will not give you this picture on the exam. I will give you LF. Okay, LF is 333 joules per gram. Okay, LV is 2,260 joules per gram. Those values will be on the front page of your unit exam. You don't have to remember them. All right, you just have to know when to use each one. I'll give you any heat capacities you need. You don't have to memorize the heat capacity chart. Any ones you need will be on the exam. Right? But you have to remember how and when to use them. Okay, and then the last thing, biomes. Got to be able to identify them from a picture and description of them. That's it. Is that very much? It is not. It is the shortest test you write in this course. As a result, please take it as an opportunity to improve the unit exam portion of your grade. It is a real chance for you to do that. Okay? Honestly, guys, the class average on this exam should be nearly 10% higher than all the others. Okay? If you prepare. If you walk into this exam going, Coderre said it's easy, it won't be. Okay? You have to know your stuff. There's just less of it to know. All right? So you don't have as much things to go over. So if you spend the same amount of time you usually spend, or maybe some of you more than you usually spend studying for a unit exam, you're going to be that much better prepared because you don't have as much stuff to master. Okay? So make sure you take it as an opportunity. It is that. Okay? It is a real opportunity to boost your mark going into the final exam. All right? Now, in front of you, you have the unit exam review sheet. Okay, on that unit exam review sheet, there's some suggestions for things to do. There are also several retired unit exam questions. Holy smoke. All right, so you've got this sheet in front of you here. Okay, it says, question number 1, describe the 4 major components of climate as they exist in Okotoks. Okay, That was a multiple choice question at some point, I think. Okay. Explain why the climate of Okotoks is the way it is by describing the factors that affect climate. So here's lesson 1. Okay, the things you need to review from lesson 1. Climate graphs, lesson 2. Okay, lithosphere, atmosphere, hydrosphere, all of that stuff is lesson 4. Or sorry, lesson 3. Okay, then you got water cycle. That was also in lesson 3. Okay, soils also in lesson 3. Solar energy was all lesson 3. Okay, wind patterns was lesson 4. Okay, Coriolis effect was lesson 4. Okay, wind patterns. Okay, heat transfer question. That goes back to lesson 2. Or sorry, lesson 3. I mean, biomes. Okay, identify this one here. By the way, these are all spruce trees. You might want to write that next to the diagram. It's hard to see. Okay, but these are all spruce trees. Okay, specific heat. There's a problem there for you to try. A latent heat problem for you to try. Okay, and number 16 is an application question that basically ties everything in the unit together into one question. All right. So in number 16, you've got to think about latent heats, the water cycle. Okay, energy budgets, energy transfers, okay, things like that. You're tying kind of everything together there. That's the hardest question on that review sheet because it is the most important on that worksheet. Hint, hint. All right, go over your stuff. Give me a good, thorough answer for that question that integrates all of those things. Okay. Yeah, so have a look at that. Make sure you kind of do that this weekend and what's left of class today, okay, as your unit, as part of your review for your unit exam. Okay. That was, I think, what I was getting at with the hint, hint part. All right. All right, and then you've got this here, your final exam review package. Okay, so you've got a few mole equation questions. You've got some naming questions with the answers there, so you can check and see if you're doing them right. All right, you've got some reaction balancing. You've got some reaction stuff here where you've got to write the reaction properly, okay, and balance it. Okay, quite a bit of that actually, because there's several marks available on the final exam to do with reactions and balancing and predicting and stuff like that. Okay, some more mole equation calculations. Stuff here on lesson 1 about the models of the atom and the atomic theory. Okay, structure of water and solubility, that polar nature stuff that you probably want to go over. Okay, 15 is a solubility question, very much like one you had on your unit exam. Okay, and guys, every one of the questions on here is a retired final exam question from previous years. All right, so this gives you a pretty good idea of both what I'm going to ask and the level of difficulty I will ask it at. Okay, if you do not do this package as part of your final exam review, you are crazy. Okay, that is the nicest way I can say that. If you do not use this package that contains questions I have formerly had on my final exam, you are crazy. Okay, make sure you use it. All right. And then down below here again, identify the type of reaction, write the balanced chemical reaction, okay, and predicting the products there. So lots of stuff on chem because that was the longest to go, okay, and it's probably the one you need to review the most because it's least fresh in your mind. Okay, there's some life science stuff, some diagrams here, very much like the ones you have, right, where you can practice your identification and your naming and figuring out what part does what and all of that kind of stuff. There's some stuff in here on cell transport. Okay, so you make sure you go over diffusion, osmosis, and active transport so those are clear in your head because, again, I'm going to ask them similar to what I did on the unit exam. You know, here's a situation, which cellular transport principle is going on there. All right. You know, part of it's going to be how plants work, structure of the plant, you know, the spongy layer and all that kind of stuff. Okay, and then some stuff on physics, basically just some problem-solving stuff. These are all old problems that were once on final exams. Okay, some of them are work energy theorem, some of them are law of conservation of energy, some are acceleration, some are V equals D over T. Okay, yours actually I inserted because this is an old version. Yours actually also has a graph on it. Okay, so one graphing interpretation question on there for you to practice with as well. And then a little bit more stuff from Unit 4. Okay, there's a latent heat question, a specific heat capacity question, climatogram question. So basically, this is what I told you would be on your unit exam. Okay, could also be on your final exam, right? Things like that. All right, so again, it gives you a pretty good idea of what to look over, and then on the other side of that, or the front page of that, you've got basically skills for each unit you have to demonstrate to me, key concepts from each unit you need to study and go over, right? So you know what to study, what things to read over, what parts of your notes package to highlight again or make sure that you review. Okay, that's what this page here is for. All right, questions on any of that stuff? Okay. Unit exams on Monday, so make sure you're ready. Okay. Tuesday, if you have questions that you would like to have answered, okay, Tuesday will probably be your only class time for that to happen. Okay, and then if you need help on anything, all right, before the final exam, Wednesday and Thursday, you've got to get in here and see me. I will do my best to stay in my room all day those 2 days so that you can find me easily and ask questions if you need to. All right, if you come looking for me on Friday morning before the exam, you will not find me. Okay, for 2 reasons. I'll be hiding in the gym because I'm the head examiner that day. Okay, that doesn't mean I'm going to be checking your head for anything. It means I have to make sure everything is set up in the gym for your unit exam. So I will not be available to help you if you are in a panic on Friday morning. Okay? Everyone follow me there? So if you want help, you got to make sure you get in Wednesday or Thursday because I have to be here early and get the gym set up on Friday morning. So I can't help you Friday morning. Okay? Questions on any of that? All right. I'm here to help you. Okay? But you're going to have to get yourself in here and ask for help. Okay? All right. You got about 10 more minutes, 10 or 15 more minutes. Okay? I'd be working on either one of those review packages right now if I was you. Are there any questions to do with the unit exam review? Okay, get to work then, guys.